Hello and welcome. In today's tutorial, we're diving deep into the world of hierarchical clustering using Java. Whether you're a data scientist, a machine learning engineer, or just a Java enthusiast, this video will equip you with the knowledge you need to perform hierarchical clustering on your data. Let's start with a brief overview of hierarchical clustering. Hierarchical clustering is an algorithm that seeks to build a hierarchy of clusters. It is divided into two main approaches: agglomerative, which is a bottom-up approach, and divisive, which is a top-down approach. In this video, we will focus on the agglomerative process, which is more common. The main idea behind hierarchical clustering is to treat each data point as a single cluster, and then iteratively merge these clusters based on a distance metric until we obtain a complete hierarchy. The distance metric can be selected from various options, but we will use Euclidean distance in our example. We'll also use the average linkage method to compute the distance between clusters. Before we start coding, let's set up our Java environment. Make sure you have Java Development Kit, JDK, installed. You can download it from the Oracle website. I recommend using an IDE like IntelliJ IDEA or Eclipse for an easier coding experience. Once you have your environment set up, create a new project called Hierarchical Clustering. Now, let's begin by creating a class called Hierarchical Clustering. This class will be responsible for performing the clustering. We will also define a helper class called Point to represent our data points in 2D space. The Point class has two properties, x and y, which represent the coordinates of the point. You may add other properties later, such as an identifier or label if needed. Next, let's define our hierarchical clustering class where we will implement the clustering algorithm. We'll store our points in a list. Now, let's implement a method to compute the pairwise distance between the data points using Euclidean distance. This method will be crucial for our clustering algorithm. In the Euclidean distance method, we calculate the distance between 2 points using the distance formula. Now that we have our distance function, let's move on to the core part of the hierarchical clustering algorithm. Here, we're initializing our clusters where each data point starts as its own cluster. Next, we need to implement an iteration that continues until there is only one cluster left. In the first loop, we're trying to find the two closest clusters. We do this by calculating the pairwise distance between all clusters using the Calculate Cluster Distance method, which we will implement next. In Calculate Cluster Distance, we sum the distances between all points in the first cluster and all points in the second cluster. Finally, we return the average distance. This allows us to find out how close the two clusters are from each other. Once we've found the two closest clusters, we merge them and remove the second cluster from our list of clusters. Once we have only one cluster left, our clustering process is complete. Next, let's test our hierarchical clustering implementation. We will create a main method to run our code. In our main method, we create a list of point objects representing our data. We then instantiate our hierarchical clustering class and call the perform clustering method to start the clustering process. Now let's run our program. If everything runs smoothly, you should see the clusters being merged in the console. However, we want to improve our program by visualizing the clustering process so that we can better understand how the algorithm is working. We will use Python's matplotlib for visualization, where we will scatterplot our points. However, you need to adapt this part into Java by using libraries such as JFreeChart or JavaFX for graphical representation. The aim here is to show the clustering visually as it progresses. In the final version of this program, it would be beneficial to output each stage of the merging process so that you can see which points are being clustered together. You can modify the perform clustering method to include logging statements to track the changes. This simple addition allows you to observe the algorithm's progression. Some additional features you might consider adding include 1. Different distance metrics, Manhattan distance, etc. 2. Cluster evaluation metrics, like silhouette score. 3. Saving clusters to a file for further analysis. That wraps up our tutorial on hierarchical clustering in Java. Throughout this video, we built a foundational understanding of hierarchical clustering, created a simple clustering algorithm in Java, and explored how to visualize the results. If you enjoyed this video, please consider liking, sharing, and subscribing for more Java tutorials. Feel free to leave your questions in the comments section below. Until next time, happy coding!